Okay, we're going to look at the same circuit, but without the manual switch. So we have the positive leg of the LED in our positive on the bus. That is going to the emitter of our transistor, so the first leg. In the base, I have a resistor that jumps me over to the other side of the breadboard. So I will power that in a moment. And then on the negative side, or the collector of this transistor, I've got a resistor that goes from that leg to the ground. Okay? And now what we're going to do is we're going to put a lead into our bus on the positive line, and we're going to run that over to the other side of the breadboard, and we're going to put that into the other side of the resistor there. So now we are feeding the base of the transistor and turning on that switch. Okay, so there you see it without a manual switch. Now, that shows you that you don't have redundancy like we saw in our last example, where a manual switch then turned on the transistor, which itself is a switch. So one switch is just turning on another switch. That's kind of silly, but now you can see that it's actually useful to have a transistor where we can turn that switch on with a signal, with a power signal. So now we could hook that up to a microcontroller and turn that switch on and off electronically on demand, and make decisions about when the switch is on or off, and not have any moving parts or manual parts. So this just gives you another perspective on this circuit.